Dr. Meher from A1 Institute, Chandigarh, and today we are going to start with a very important topic, that is electricity. This chapter is considered to be a very difficult one by the students, so I have tried my best to make it easy for all of you. Let us start with this chapter, electricity. So electricity is what? Flow of electrons. Flow of electrons is known as the electricity, electric current. Electrons, they always move from negative to positive charge. And this is what is known as electronic current. Electronic current is flow of electrons from negative to positive charge. Now, what is electricity? We will be discussing few topics in this. So, let us start with the charge. I always ask my students to learn this in a way like Q equals to IT. You all know IT part, so it is easy to remember Q equals to IT. So, I will be equal to Q upon T. Anything divided by time is considered to be rate. So what is I? I is equals to Q upon T, and anything divided by time is known as rate. The rate of flow of charge. So I'll be telling you each and everything, every identity in detail. This is known as charge. And SI unit of charge is Coulomb. Coulomb. After the name of scientist. And SI unit of current is ampere. SI unit of current is ampere. Again after the name of scientist. This is the current. Current is represented by capital I. This is time. And time, SI unit of time is second. So in other words, we can say 1 ampere is equals to 1 coulomb upon 1 second. So again, a very important question. What is current? Current is defined as rate of flow of charge. I told you in the beginning, anything divided by time is known as rate. So what is current? The rate of flow of charge. And what is ampere? 1 ampere is equals to rate of flow of charge flowing in 1 second through 1 coulomb. Rate of flow of charge of 1 coulomb flowing through in 1 second. Flowing through a conductor in 1 second, that is known as 1 ampere. I hope it is clear. Now ampere is given after the name of a scientist. Ammeter is an instrument which is used to measure the current. Ammeter is an instrument which is used to measure current, and it is always connected in series in a circuit. We will be discussing the circuit in detail. Then I will be telling you what does I mean by the series. So the ammeter, which is an instrument used for measuring current, is always connected in series. Now I am coming to another topic, that is potential difference, V. Potential difference is defined as work done per unit charge. As I told you in the beginning, that flow of electrons, they flow on their own. So there is no need to work and there is no need to do any kind of work in moving electrons. But in order to move a positive charge, a unit positive charge from infinity to a particular point, any point A or B, some amount of work has to be done. So this amount of work, and just listen to me carefully, amount of work in moving a unit positive charge from infinity to a point is known as electric potential. So V is what? Electric potential. Electric potential is what? It is amount of work done in moving a unit positive charge. A positive, unit positive means plus 1, unit positive charge from infinity to a point. SI unit of potential difference is volt. SI unit of work done is joules. Again after the name of a scientist. SI unit of charge is coulomb. So in other words, we can say 1 volt is equals to 1 joule upon 1 coulomb. So 1 volt is equals to 1 joule upon 1 coulomb. And here we have voltmeter. Voltmeter is an instrument which measures the change in potential difference or electric potential. We have done this V. This is also known as electric potential. What is the definition for electric potential? Amount of work done in moving a unit positive charge from infinity to a point. What is 1 volt? It is defined as work done in 1 joule in moving a charge of 1 coulomb from infinity to a point. And this voltmeter is an instrument which is always connected in parallel. So again, I will be discussing this topic in the end. This is parallel. Now coming to very important topic, that is resistance. Another topic is resistance. Please listen to me as these topics are very important. Now coming to another topic, that is resistance. Resistance is the opposition to the flow of current. Opposition to the flow of current is known as resistance, and it is denoted by capital R. If we look at the formula of resistivity or resistance formula is R equals to rho L upon A, where R is resistance of a conductor, rho is specific resistance, L is length, and A is area of cross section. And R is resistance. Resistance is what? It is the specific resistance of conductor of length L and area of cross section A. In other words, if I need to find out the formula for the resistivity or specific resistance, I will say rho equals to R into A upon L. What is specific resistance or resistivity? It is defined as resistance of conductor of area A and length L. Yeah, of area 1 meter square and length 1 meter. This is specific resistance. If we look at the SI unit, the SI unit of R is ohm, and the symbol is omega. Like alpha, beta, theta, we have omega also, and this is for resistance. Length is measured in meters, area is meter square. So if from this we can find out the SI unit of rho, which is equals to rho meter. You can calculate because rho into meter square upon meter comes out to be rho meter. So what is the SI unit of specific resistance? It is rho meter. And this specific resistance is dependent on this important factors, or the resistance of conductor depends upon, you can look from the formula that it is dependent on the length of a conductor, it is dependent on the area of cross section and nature of material. So all these factors, they are, and the resistance of conductor depends upon. Okay, I hope these three things, that is Q, V and R, they are all clear to you. Now we are coming to a very important topic, that is Ohm's law. Ohms is again a name of a scientist. Ohm's law. He combined all the identities like V, I and R and find out the formula. According to Ohm's law, potential difference between two cross section of a conductor is directly proportional to the current at constant temperature. I'm repeating it again. If all the physical quantities like temperature, air pressure, they are constant, the potential difference is directly proportional to the conductor. And if we remove this proportionality sign, we'll get the formula, we'll get this constant, which is R. R is also equals to V upon I. And he used a circuit diagram. To represent all the quantities. In the circuit diagram, we have a conducting wire, we have battery, we have a key, and it has a resistance. The voltmeter is added in the parallel to the resistance, and ammeter is added in the series connection. Okay, and for making the symbols, we need to add plus here with the big plate and minus with the small plate. If the key or the switch is on, the current will start to flow from the positive charge. It will pass from the voltmeter and ammeter. And I already told you that ammeter is always connected in series. In series means it is connected in the same wire as that of resistance, and voltmeter is connected in parallel to the resistance. Okay, so he used this circuit diagram, and with the help of this circuit diagram, he concluded that V is proportional to I, that is potential difference is directly proportional to current at constant temperature. And when he equated all the values of V and I, we found out that it is a straight line graph, and this is given by a slope, that is resistance. So what is resistance? Resistance is equals to V upon I, and I have already shown it to you. So with the Ohm's law, you need to give this statement, you need to give this V is proportional to I, you need to make this circuit diagram and this graph also. Okay, I hope this part is clear to everyone. Okay, now coming to another part, to another topic, that is combination of resistance. They can be connected in series, that means within the same wire, or they may be in parallel. So first of all, we will be starting with the series connection in series. In series, you will see all the resistances, that is R1, R2 and R3. These are the symbols for resistance. They are connected to a same wire, but the voltmeter is always connected in parallel. I told you in the beginning, ammeter is connected in series with the battery and the key. And if this switch is on, then the current will start to flow from positive to negative charge. But in case of series, the current is same. So just remember this thing, that in series, I is same. And from Ohm's law, V equals to IR. So in this case, as the current is same, it is equals to V equals to V1 plus V2 plus V3. This is V1, this is V2, this is V3, and I is same in all the cases. So now if I am from the Ohm's law, what was the Ohm's law? It is equals to V equals to IR. From Ohm's law, I am putting all the values IR equals to IR1 plus IR2 plus IR3. If the I is common, we are left with only RS equals to R1 plus R2 plus R3. So this is your combination in series. This is the equivalent resistance in series, that is RS equals to R1 plus R2 plus R3. Now coming to the parallel combination, in parallel we have V same. Now I am making a parallel connection where all the three resistances are in parallel, R1, R2, R3, and they are connected to the voltmeter, which is again in parallel. They are connected to ammeter, which is in series. I hope it is clear with everyone now. I am adding battery and key. If the switch is on, the current will start to flow from the positive to negative part. The conventional current always flows from positive to negative, which is opposite to the flow of electronic current. That is why I am making it from positive to negative. In the beginning, I said that flow of electrons, but when we make it conventionally, the conventional current always flows from positive to negative. This is your complete circuit diagram, and in case of parallel, V is same. From Ohm's law, what was Ohm's law? V equals to I. But in this case, V is same. So I am using this value I equals to I1 plus I2 plus I3. I am putting the value of I from the Ohm's law. V upon R equals to V upon R1 plus V upon R2 plus V upon R3. We have this common, so I am left with only R1 upon RP equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. These are the three, this is the equivalent resistance for parallel connection. I hope these two things are clear to everyone. Please try to remember these things, and as these two topics are very important from your board point of view. Now I am coming to a very important topic, that is heating effect of current. Heating effect of current. In Joules, this was given by scientist Joules. So Joules heating effect of current. He gave a formula. H is a form of energy, that is heat energy. Work done is a form of energy, and you know the formula of work done, that is power into time. So I'm using this formula, power into time, that is work done. What is the formula for work done? As we did initially, or अगर आप लोगों को याद हो, we have done this formula, that is V equals to W upon Q, and I'm putting this formula here, that is equals to V into Q, and Q equals to IT. I told you in the beginning only, so this formula is VIT. So H, that is heat energy. Work done is a form of energy. So we have a formula, H is equals to VIT. If I put the value of V equals to IR, then it will be I square R into T. If I put the value of I here, that is V upon R, then it is equals to V square upon R into T. So these all are the formulas of heat energy. And then there is a practical application for this heat energy. Practical application of heat energy. It is used in electrical appliances. First application is, it is used in electrical appliances. You must have seen in case of heater, geyser, where electric energy is converted into heat energy. So all the appliances, they are based on this fact of Joule's heating effect of current. That current, the more amount of current, more amount of heat will be generated. This is dependent upon square of I. I hope it is clear with everyone. And another thing, it is used in making safety device, that is a fuse wire. Fuse wire is a short length wire of appropriate melting point. Okay, it is always connected in series with the main circuit. It is a safety device, and the fuse wire is a short length wire which is of appropriate melting point. And it is always connected in series, that I told you just now. Now we are left with a very simple topic, that is power. So power, in case of power, you need to divide work done by time. So I will tell you the formula for power. Power equals to work done upon time, and you know what is work done? VIT upon T, I square RT upon T, V square upon RT upon T. So we have a formula, that is VI, P equals to VI, P equals to I square R, P equals to V square upon R. So this is the formula for power. And the SI unit for power is watt. 1 watt is equals to 1 joule upon 1 second. Work done की SI unit क्या है? Joules. And for commercial unit of energy, we have 1 kilowatt hour, which is equals to 3.6 into 10 raised to power 6 joules. 3.6. 1 kilowatt hour is equals to 3.6 into 10 raised to power 6 joules, because 1 kilowatt is equals to 1000 watt. 1 hour is equals to 3600 second. By multiplying 1000 with 3600, the value comes out to be 3.6 into 10 raised to power 6 joule. So commercial unit is known as 1 kilowatt hour, which is also known as 1 unit. I hope you are clear with all the topics. Thank you, good luck and God bless.